In this video, we look at applications of normal distributions. So remember, a normal distribution is a distribution of data that has a bell-shaped curve to it. Remember that all normal distributions are symmetric and centered around their mean. And so we started by talking about the standard normal distribution. Remember, the standard normal distribution has mean 0 and standard deviation 1. So recall that if we have any other normal distribution and we know the mean mu and the standard deviation sigma, we can convert to z-scores, and then this will have a standard normal distribution. So if we have any other normal distributions, the idea is to convert the numbers to z-scores. If I have x is normal with mean 100 and standard deviation 5, I can convert values in terms of how many standard deviations they are away from the mean. Then I can use the standard normal table to look up probabilities. So let's look at an example. Suppose human body temperature is normally distributed with mean of 98.2 and standard deviation 0.79. So if I wanted to know what's the probability a randomly selected person has a body temperature below 97 degrees, the idea is I want to convert that 97 to a z-score, or think how many standard deviations below the mean is 97. So if I take 97 minus the mean over the standard deviation, I get negative 1.52. In other words, 97 degrees is 1.52 standard deviations below the mean. Well, now this is a z-score. I can go to my z-table and find the probability of z less than negative 1.52. If I look up negative 1.52 in the table, I get 0.0643. So there's a 0.0643 chance that a randomly selected person has body temperature below 97 degrees. Suppose I wanted the probability between two values. Again, I need to take the 98 and 101 and think of them in terms of how many standard deviations above and below the mean these values are. So here I have two z-values. 98 minus the mean over the standard deviation, 101 minus the mean over the standard deviation. So 98 is about a fourth of a standard deviation below the mean. 101 is about 3.5 standard deviations above the mean. So now to find the probability between two z-values, I look both of them up in the table and subtract them. So note here when you look up 3.54, that's off the table. And there's a little note at the bottom of the table that says if it's over 3.49, use 1.00, because practically all the data is less than 3.5 standard deviations below the mean, or above the mean in this case. When I look up negative 0.25, I get 4013. So the area between 3.54 and negative 0.25 is 5987. Similarly, the area between 98 degrees and 101 degrees would then be 5987. So about a 60% chance someone has a body temperature between 98 and 101. Last example, suppose I wanted the middle 95% of body temperatures. So here I want to first think about, let's first find the middle 95% of z-scores. So if I want 95% in the middle, that would imply there's 2.5% in each tail, because I know the total area has to be 100%, or 1. So if I focus on that lower end there, I want to look for a z-value that gives me 0.025 in the lower tail. So here we're using the table in reverse. So instead of looking down the left side and across the top for a z-value, I'm looking inside the table, trying to find as close to 0.025 as I can. Well, if you do that, you find 0.025 in the table, and that corresponds to a z-value of negative 1.96. So since I know the z-distribution is symmetrical, I know that positive 1.96 would then cut off the upper 2.5%. So the middle 95% is the values that are 1.96 standard deviations below the mean and 1.96 standard deviations above the mean. So if I take the mean of 98.2 plus 1.96 standard deviations, that would give me my upper limit. If I take the mean of 98.2 minus 1.96 standard deviations, I get the lower limit. So 95% of body temperatures are between 96.65, and 99.75.